All right, hi guys. Yeah, so it's been a while. Yeah, during my hiatus, I got fatter. So I've started working out. I am working on mind and body, getting them all, back to where they should be. Started working with Ramon. I basically I will import the arm out of the CAD, and I will go ahead and I'll do a pack and go, get an exact copy of the arm as it is in the CAD, and then I'll go ahead, do my work, and then me and Ramon will get together on Sundays, which is the only time both of our schedules allow for now. And we go ahead and we integrate all those designs into the, he does the hard work. I do the easy work. I figure out what needs to be done, and he does the hard work by actually doing it, getting it all in the CAD and things like that. So this is just the elbow drive portion. There's no finger articulation or wrist articulation in here yet. Needed to, hey, you gotta get that whole elbow working first. So, yep, this is the arm, of course. I'm going to go ahead and change transparency here, change transparency here, and yeah. So, no belt drive on the outside, okay? Everything is for the elbow drive is on the inside, okay? So there's that. So what I'll do here is let me focus on the elbow first, I guess. Okay, so we're going to be using the steering servos that are available for the ASME servos. Okay. We'll use one on this side, which will drive this side plate here. Okay. And in this particular version, this is kind of a, hey, I'm paranoid upgrade version, slightly paranoid. We have a modified plate here where the hub has been removed, so you get a little bit of the advantage of having a partial D shaft there to engage this side, and then that will drive this side. This collar here, this two-piece locking collar, is to prevent this plate, this side, from possibly flexing out on you during a heavy load. There is another, you don't need to have this if you're not paranoid at all and you're happy with just one side driving. Well, then you could use a simple, single set screw locking collar on here. You don't even need this two-piece one. Just something to kind of, keep those plates from being able to maybe move this way on you under load. If you're like me and you're extremely paranoid, I do have a third option, which is the Muy Grande, which basically is taking the steering servo and facing off down to about here. Okay, so facing off a good portion of it so that it clears this covering on this side, and then drilling another set screw right in this area here to take over the place of this one. And then you have set screw engagement, you have more D shaft engagement. That would be the Terry, hey, I'm paranoid as hell version. And I have a lathe, and I don't mind doing a little bit of extra work. So this is all sandwich based, okay? So when you go ahead and when you go to disassemble this thing, okay, let me I'll tell you what, I'll just go ahead and get these coverings out of the way here. I will hide them completely just so we have a clean slate. Let me see. There we go. That gives you a little bit more. Yeah, so disassembly, yeah, you remove the 9 screws here from this plate. You loosen this set screw, and yeah, Ramon, we got to re-index this. This is in the wrong position. We just got to clock the holes in these plates different. That was a miscommunication on my part with Ramon. You loosen this set screw, loosen this set screw. You come over here, you remove this collar or loosen the set screw, whatever it is. But anyhow, and actually, yeah, yep. And then this plate comes off, which then allows you to remove the entire rest of the arm going out in this direction, okay? Then that allows you to be able to get to all the perimeter screws around here to unbolt this plate and remove it, okay? As I said, this is sandwich based, so it's a layering of things. Please, this is the wrong diameter. In the CAD I worked on, for some reason, this was a larger diameter. In this version, it's much smaller. So yeah. Anyhow, so there is a nylon spacer in here to prevent this plate here and this plate here from having metal-to-metal contact. Okay. So that's what that's for. It's an 8mm D shaft that goes through here. Unbeknownst to me, 8mm D shaft raw stock doesn't seem to be a thing, so we'll have to make them or have them made. The largest size they seem to come in metric is 6mm. So over here, what we have is we have a spacer here, 2 spacers actually. We have a red and a purple. That is to get this flanged bearing here so it does not protrude through this metal plate. Actually, let me do a split view here for you. And yeah, that should be good enough. And here we go. And yeah, so that this flange bearing, this 8mm flange bearing, does not protrude through this plate, which then would impede upon the nylon bushing here. Okay, and I don't know. Yeah, are these centered? Don't know what's going on there. That's a weird rebuild artifact, I think, with this D shaft. Yeah, that's weird. Or I got it clocked wrong. Or not. I don't know. Okay, so anyhow. So you've got these things here. These are readily available off the shelf from McMaster Car. These round shims here, ring spacers. I think they're all ring shims. I think they're also called. Servo City is where we get these spacers. These are the same exact ones. Or no, they're not the same exact ones. They're 8mm diameter ones. But they're the same basic type that we use. The Delrin acetal shims that we use from Servo City. We buy them from there. This is a T5 timing pulley. This has quarter 20 set screws in it. We tried to go a little bit larger, but we were unable to. So yeah, that's what it is. Quarter 20. We couldn't. Yeah. With everything going on in the widths that we have and we're working with, yeah. So it's 625 thousandths in width here. This is a 15mm T5 timing belt here, the old big orange thing. Okay. Up here you have an idler pulley. Okay. So this has I believe it's a 125 stainless steel dowel pin. And then these are aluminum spacers that we buy from McMaster Car. These are held in place by something which is not here right now, which is a 3D printed core, if you will. Okay, and these will actually be countersunk. There'll be countersinks in there to accept these round spacers within the 3D printed core, and that keeps them locked into position. And of course, this nylon piece here, which is what this is, it's actually a nylon spacer, and again, that's from McMaster Car. In here, everything fits, but you can see there's no gap here. Basically, builder modification. You're going to get this spacer, and you're going to get out a piece of sandpaper, and you're just going to sand off a little bit, 10 thousandths or so off of one side, and then that will allow the room to be able to, rock and roll in there and not have an issue and spin freely. Okay, and then of course we go over the other side here. You can see that. So there we go there. All right, so our belt path is, let me unsuppress this or unslice it. Kyle, we put in, as you suggested, we put in a bearing up here, 8mm by 16 by 5. We used one of these somewhere else. It escapes me where, but there's somewhere else in the CAD we actually use the same bearing. Okay, to support that ASME servo shaft at the other side, so no problem there. The servo itself does not move. There's not all the screws in here, but that is fixed now. Okay, we do all of our idler or tensioning adjustments on the idler with this. Now this is actually a good spot to show you where let me see if it slices. Nope, it didn't slice where I wanted. Give me a second here. Okay, let me see. Go like this, go like that, do that, and move that up some. Here we go. Up, 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 up. And yeah, that should be good right about there. Okay. So, in here, yep, this is the tensioning thing. Dave Stapley, thank you. Yep, we used your idea. This is his idea. But by using okay, I didn't go up high enough. So frustrating. Let me try a little bit higher this time, dummy. There we go. Okay, that should do it. Now we got the fastener in there. Okay, so this is a spacer, 7/8 wide, which is 0.875 in width, sandwiches between the two metal plates. The nylon spacer here, again, this rotates on that stainless steel spacer here, and gives you, it's the roller surface. We were able to source through McMaster Car a larger diameter for this particular one, because I had concerns that there wasn't enough meat on the bone in this slot area. So we did that. We have washers out here. Again, we don't want to mar up the aluminum plates. And basically, this is what you slide this idler up or down to tension the belt. And then lock, and then tighten it down, and that sandwiches everything together and locks it in place. And as I said, we couldn't find, you can see here where these shims actually impede into the roller bearing. Again, these shims, they vary too. They have a variance manufacturing tolerance, so you're going to match them up. You're going to get a pack of them and match them up. And if you can't match them up, you break out a piece of, sandpaper and sand each one down until you get the ability for that roller to be able to spin freely in there, and then you're golden. Okay, up here, bearing, set screws, rinse and repeat. Okay, So everything is golden there. I don't think, yeah, we didn't open up that hole for that bearing. Oopsie. Got to do that, Ramon. Yeah, we did that. Yep, we did it, the 8.1 opening for over here for the shaft, but since we're and that's the other thing we're doing too. Let me unsplice this. Is the arms are now mirror? They're both. Yeah, we just have one arm made, and it can be used for either side. Okay, so it will have all the features on both plates. So far, it'll work out. So this bearing hole will actually be in this plate over here. Same thing. So yeah, so let me see here. We'll hide this. So there we go. I mean, you can see the belt path. Okay. It's very, a very thin profile there. Let me hide this. Change transparency. And change transparency. And change transparency. Okay. So there, you can get a, yep. We did this, so we're taking up less space internally. We have wiring on the inside, or will, so we want that. We need that room. The other thing is, the main reason is I wanted to wrap around these pulleys more, so we're getting more tooth engagement, so there is almost zero possibility that the belt would be able to slip, even if the belt's a little bit loose. So yeah, so that shouldn't be a problem whatsoever. And yeah, we should be golden. So this is simple. Yeah, and like I said, you remove the plate, and then everything comes off as a sandwich. You'll be able to. The belt will be loosened up. Yep, this bolt won't be here because you need to remove this, or this screw, because you need to remove that to remove the outside plate, which means these washers aren't in the way. So yep, everything goes together from the top down in this direction. So from this side over here, or actually you start at this side. You start assembling it, you put you bolt the servo on to the plate, and you start working upward from there until you get the whole thing assembled as far as the belt drive. Should never need to be serviced. There should really be no reason you ever need to even go in here. So yeah. The only thing I think I might do, and I mentioned this to Ramon, he didn't see it, but I think I might do a slight cutout in the metal so you can actually maybe see the belts, or maybe they'll be viewable from the top, but something so you can see if the belt's starting to wear or fray away or something like that, without having to take the whole damn arm apart to get to be able to get eyes on it. So there it is, guys. I hope this video is not too long. I'm glad to be back working. It feels good. And yeah, comments, questions, concerns, improvement suggestions, anything like that, let me know. But this should be rock solid. Yeah, it should. Yeah, if you're gonna be that person that runs this thing under a heavy load just to, shits and giggles, showing off to the friends or to the, significant other, this will do it quite easily. There won't be any problem there. There won't be a failure. Any failure that's going to happen is probably going to be the servo stalling. But nothing here as far as the belt drive is going to fail on you. And it should last for years. And yeah, and that for, those of you that are operating it normally, you should never have to touch this. It should, you put it together and you should never have to look at it again. So yeah. Unless of course something else fails, like, internally the cabling and things like that, because that's the thing. All of the all of these pulley cables and finger cables, they'll all now run internal. So they will run down through here and up through they'll go inside, and then they'll come out through, you know, like the side plate. There'll be like a slit in here for it to be able to come out and go to the servos, which right now the working, you know, what I'm going to try to do is get all the servos mounted on the outsides of the plates and all the electronics. So you can mount the electronics to the outside of the plate. So the only thing that really will require any sort of maintenance on the inside is the belt drive. And like I just said, theoretically the belt drive should last you guys forever. Well, and the wiring. There's wiring in there too. There will be wiring, but there again, yeah. And there will be a 3D printed core in here to keep wires. You know, these belts basically are going to have, you know, little walls that come up so that nothing can ever touch or hit them internally. So if the cable comes up near here, it's just going to hit a 3D printed, you know, wall that blocks it, because the belt's on the other side of that wall, if you will. Alright guys, I hope that I've made myself, you know, clarified things enough for you. Kyle and Dave Stapley, thank you so much. I really appreciate you two taking the time to talk to me and tell me what you've done and what worked for you, what didn't work, what you know, seen as a problem, what you found that worked, and things like that. And I know Kyle, he's been working on the finger articulation with 3 individual fingers. He showed me a video, and oh my god, the fingers movement is so fluid. So actually, I'm going to be, he based his finger cable pull off of some of the preliminary work that I did, and I'm going to take some of what he did, because he didn't do it exactly as I did it, and going to kind of take the two, meld them together, and come up with what should, you know, hopefully be the best of both worlds. Alright guys, that's it. Yep, talk to you later. Bye for now.